Hey everyone, and welcome to another Dapr University workshop. In this workshop, we're going to talk about Dapr Workflow and the durable execution concept, which you can use to build like very resilient distributed applications. I'm Mark Duiker. I'm the developer advocate at Digrid, and in my role, I create a lot of content for Dapr open source. And one of the things that I've created is these learning tracks for Dapr University. Maybe you've also joined an earlier track about the Dapr 101, which explains the most Dapr basic APIs. But in this workshop, we're going to do some hands-on learning about Dapr Workflow. All right. So the first thing what we're going to do is if I can copy this, yeah, I'm going to ask you to go to this website because we are going to use Dapr University. Please click on this link. It's the second learning on that page here. So if I scroll up here, so this is the Dapr University website hosted by Digrid, and these are Dapr tracks that I've created. So the first one is the Dapr 101. We're not covering this today. This was part of an earlier workshop, and we're going to rerun this again in a couple of weeks. But today we are going to start this one, Dapr Workflow, use durable execution to build reliable distributed applications. So if you could click this button to start the course, right? You'll be asked to enter your name and your email, and it's important that you use a business email or at least an email that's not a Hotmail or Gmail or Outlook. So please use that. So as soon as you have entered your name and your business email, you will see another window to actually start it. So if you then click start, you will see this window, which mentions a couple of things. So first, there is like a start button at the bottom right you need to click, and then this online sandbox environment will start up, and it will take like, I think under 2 minutes. You'll see a countdown here once you start. And this environment will be active for like 90 minutes. And I think we need maybe 50 or 60 minutes to complete everything. But in case you need more time, it will be available for 90 minutes. Now, what's important to realize is if you leave your computer, so if your session will be idle for more than 10 minutes, this online environment will stop. And you can then still restart the environment, but the progress that you made is then lost, which is not a very serious thing, but because all of the challenges that we're doing are not building on top of each other, but it's important to know that you are sort of restarting this whole environment. And to get back to the last challenge that you're working on, you can go to this progress menu here, and here you can click on any challenge that you want to run. Because as I mentioned, there's no real dependency between all of them. This is the most logical ordering, so I'll be running it in this order. But if somehow your session is expired and you need to continue, you can start up this environment again and then just click on whatever challenge you want to continue with. All right, so my environment is ready, so I can click the start button. I will wait briefly for you to also. So here your environments are also ready. So in the meantime, in this first challenge, I will give like a quick summary on the first challenge. So in this first one, I'll explain what durable execution is and why it's beneficial for building distributed applications. I will also explain that most workflow engines implement this durable execution concept, and what workflow as code is and how Dapr supports this. Now, there's a lot of documentation available about Dapr, so if you at any moment need more information about Dapr Workflow, there's this link here. It's also mentioned in all of the other challenges as well. So this brings you to the official Dapr docs with more information about workflow. And I can also recommend you to join our Dapr Discord server. There's a dedicated university channel for you to ask questions, but there's also like a dedicated workflow channel there as well if you have more in-depth workflow questions. All right, I am going to click start here. So I hope you are ready as well. All right, so in this first challenge is more like a bit of theory about durable execution. So there's no hands-on part in this first challenge, but from the next challenge onwards, we're going to actually run some Dapr workflow applications. So I think we all realize that it's quite normal for IT systems to fail, right? I mean, sometimes even in the news that maybe like entire cloud providers or regions are down, and it's not very uncommon that applications are not available some part of the time. So it's also not realistic to think that all systems are available 100% of the time. That will never be the case, and especially when you're developing distributed applications, right? Because you are communicating across like many different services and many state stores and message brokers, and it's quite likely that some of them will have some downtime, and that can have an impact on your entire system. So you really need to be very thoughtful how to handle like these temporary failures and implement retries, etc. And to a large extent, that's already built into Dapr. So if you're already using Dapr, that has like built-in retry policies, which is great. But yeah, there's actually something more we can do to make durable execution possible. And so ideally, if there is some major failure of our application and the whole application like breaks down, ideally we want to recover from that failure in an automatic fashion, and so without any manual interaction. So the durable execution concept actually guarantees that code is run to completion, even if the process that runs the code terminates, because it will actually start up another process and it will resume the code execution until it completes successfully. And how that is done is because it's actually doing a lot of state point checks to an underlying state store. And so the entire flow of your code is actually being pushed to a state store. So this principle might sound familiar. Maybe you've worked with some workflow engines. I mean, workflow engines have been around really for decades. So to automate business processes. I think it mostly began as more like visual designers. So a business user can author like a workflow using a UI. So there's always like an authoring environment. There's also a workflow engine component to it to actually run the workflow, and there's usually also a state store behind it to actually persist the state of the workflow so it can resume in case it fails. And so these three components, authoring environment, engine, and state store, those are three crucial components of any workflow system. And yeah, workflows are really ideal to handle like long-running processes, right? So maybe you are doing some kind of an approval process, like an order approval process that involves some manual steps in case you have like a manager approval. So these systems can run maybe for like minutes, for days, for months, for years, or even like indefinite. So yeah, workflows are ideal for these very long-running business processes. Some systems, or most of these systems, started out with like visual designers, but yeah, since the last couple of years, a lot of these workflow systems are based on workflow as code, which means you're not using a UI to design or to create your workflow, but you're actually writing your workflow in code. And I think that's a great step because, well, I come from a developer background. I like code, and I definitely like to write these workflows as code because, well, it's part of version control. So all of the changes will be reviewed in pull request, hopefully. You can also unit test your workflows, which is a great thing. And most of these visual tools don't have that. Of course, it can be a downside that workflow as code typically doesn't have a visual representation. So there's like pros and cons to workflow as code solutions. Now, since Dapr 1.13 or even Dapr version 1.12, there is like a workflow API. So there's a built-in workflow engine in the Dapr sidecar. And recently, since I think 1.15, that became like a stable API. So it's been on development for about 2 years. And at the moment, you can use all of the commonly used languages to use Dapr with. So you can use like .NET to author these workflows. You can use Java, Python, JavaScript, and Go. In this lesson, however, only .NET and Python are available. So if you're a .NET or Python developer, you're free to choose these two languages. I'm still working on the other languages to be added to this workflow track. So in this diagram here, it's just a representation of what lives where. So you have a workflow application that you write. So you write your business logic in your workflow application by using workflows. And the workflow is built up of small tasks, and those are called activities. And so that's all in code in your application. And your application communicates with the Dapr sidecar, and the Dapr sidecar contains the workflow engine. So, and as soon as you start or schedule a new workflow, that will be communicated to the Dapr sidecar, and that will actually initiate the execution and communicate back. So, okay, now start with execution of this workflow. What the Dapr Workflow engine also does, it will communicate all of these state changes of the workflow to a state store. And so all of the changes that we made are persisted to a state store. I've got an animation of it in the next challenge. So let's have a look at that. Okay, so I will continue with the second challenge. And that shows like the basics of how you can actually author a workflow. So I'm also show you how workflows are started and how to get the status of a workflow instance, and how the workflow engine actually persists the workflow state. All right. So a workflow, like I mentioned, is like a collection of smaller tasks called activities, but also some business logic. And so this is like a very small example of how it visually looks like. So your workflow contains like activity calls, but also some if statements or switch statements to, based on the output of an activity, choose a different path in your workflow. So I have like a very basic workflow demo in this folder, and I'll first expand this to show it visually. So what happens in this basic workflow is we will start the workflow with an input argument with a text string named 1. Then we run an activity that just simply appends 2 to this input string. So at the end of activity 1, we have 1, 2. And then we run another activity that appends 3 to the input. So the output of the activity is then 1, 2, 3, and that's also the output of our workflow then. All right, so I will run through the .NET examples here, but as you can see, you can either choose either the .NET explanation or the Python explanation. So I'll run through the .NET workflow, and here in this area, you can actually browse through the code, and these are all terminals, and we're going to run this. We're going to run some commands in these terminals, actually run the application, make some HTTP calls, and finally check the where the state lives. So if I open the basic workflow file here, so I'm maybe I should make this also a bit bigger. So if I open this basic workflow file here, so this is a C# project. I have a basic workflow class here. So workflows in .NET C# are just classes, and you are using a Dapr Workflow package in this case. And so since you are authoring workflows in a specific language, you do need the specific language package, the workflow package, because that contains some base types that you'll be using. So if you're creating a workflow, you need to use the workflow base type. So you inherit from that, and then you specify the input type of the workflow and the output type of the workflow. So if you inherit from workflow, and then you need to implement or override the run async method. And that always the first argument of the run async method always has the workflow context. So this is something that's provided by the Dapr Workflow engine. And on this context, there are like properties and methods that you can use to actually call different activities, create timers, wait for external events, etc. I will mention all of these later. And the second argument is your input for the workflow. Now the output, everything in workflows is asynchronous. So the output is async task of a string. Since I've configured that to be my output. Output types can be anything, right? So in this case, I'm using a simple type. It can also be a complex type, as long as the output is serializable. So this is a very small workflow of just 2 activities. And here you can see we are using the context, and then we using the call activity async method on the context. We specify the output type that we expect back. Then we specify the name of the activity. You can also use a string, but it's a little fragile to directly use strings. So that's why I'm using the built-in nameOf function in C# to give me back the string representation of the activity one. And I'm specifying the input for this activity. Now note that I'm awaiting this call. So what happens when we start this workflow, then as soon as we use this call activity async API, we are sending a signal to Dapr Workflow engine from now please schedule this activity one task. And what happens then, the control flow of the workflow will stop, and the Dapr Workflow engine will signal to schedule this activity. Our application will actually run this activity, and it will then, as soon as the activity is completed, then it will give control back to the workflow. I'll come back to this later. So what happens as soon as we have completed this activity, we have a result here, and as you can see, we are using this result here as an input for the other activity. And then when we call activity 2, we use that result as the output of the workflow. Now, if you look at an example of an activity, let's just use this one. It's basically the same setup. We have like a regular class. We inherit from the base type workflow activity. We specify the input and output types. And again, we have to override a run async method. In this case, we have a workflow activity context. You probably don't need it that much because the only thing that's on this context is the instance ID of a workflow. So as soon as you start a workflow, it'll always have like an identifier that's called the instance ID. And you need this instance ID to be able to do other operations on the workflow, like getting the status information or do anything other related to the management of the workflow. But that's part of the one of the last sections. And the second argument is the input of this activity. So nothing really happens here. We just do a console write line of that this activity received some input just to make sure we see something in the logs here. And we give back a result very simply append to this input. The same thing happens in activity 2, but then there's like a different, then there's 3 appended to the input. And the final thing that you need to know about authoring workflows is that you need to register them in your startup code. So here we can see the services collection, and there is an add Dapr Workflow extension method that you need to use, and there are 2 methods on there: register workflow, and here you need to specify the type of your workflow that you have written in your workflow application, and you need to register the activities. So this is something that is specific to .NET, and that is not in Python. So if you're using the Python version, you don't have to do this registration of the workflow and activities. That's been dealt with by the SDK itself. But in case of .NET, you actually do need to do this registration of the workflows and the activities. Now, this is a web application, and it also has an endpoint, start/input, and we are injecting the Dapr Workflow client, and the Dapr Workflow client is used for the management operations of a workflow. And the one that we are using is we are scheduling a new workflow. So we are awaiting this call. We provide the name of the workflow, and we provide the input. And what we get back is we get back the instance ID. So we get back the identifier of the workflow that's been scheduled. So we don't get back the output of the workflow immediately, because it can potentially be a very long running workflow that can take days, weeks, months, or it might never end. So that's why we get back the instance ID, so we can later provide this instance ID to retrieve information from this workflow. Okay, let's see if I covered everything here. Oh yeah, this is still important. So the workflow code itself is just like using the context to call activities and have some if-else statements. And these are not in this example, but they will be in later examples. But it's important that you limit your code to just calling activities or calling child workflows even. I'll get back to that in a later challenge, and some business logic and nothing else. What you do in activities, you typically call like other external APIs. So maybe you want to store some data, you execute that in an activity call. You're calling a third-party API to another SaaS service. You'll do that in an activity API. So all of the things that I just mentioned, don't put them in a workflow. The workflow should only contain calls to activities and some business logic. Okay, so now I'm going to run the .NET application. So I first need to navigate to the right folder here. And like I mentioned before, as you can see it also here in the label, this learning track just clones the Quick Starts folder. And inside the tutorials, Quick Start, Workflow, C#, I'm navigating to these different folders for all the different exercises. So I'm also going to point the terminal to the fundamentals folder now. And I will now build this solution. And the first time it's probably going to take a bit longer because it also needs to do a .NET restore, or in case in Python you do need to do like an installation of your requirements file. So initially you need to download all of your dependencies. So that probably takes some time. But on the other challenges, it will be a bit faster because you've already downloaded all of these. Okay, so it built my my small solution, and now I'm going to use Dapr multi-app run to start my solution. Now, if you're not familiar with Dapr multi-app run, so that's this command that I'm running, Dapr run -f and then dot. What this means is I'm going to run Dapr, but I'm specifying a file. So what the -f means, and the dot means where's the location of the file. Now, there's in the root here, there's a dapr.yaml file, and this contains a definition of the applications that I'm going to run. In this case, it's just one application, but multi-app run is really useful when you want to run and start up multiple applications at the same time, because this is basically like an array of different applications. In this case, it's just one application. I'm also pointing to a resources path, and this contains a YAML file that describes what kind of underlying state store I'm using. But I'm postponing that for just a few minutes. I'm coming back to this later. Now let's run this command, and it will create a new application ID. It will go to this folder. It's going to run .NET run to actually run my .NET application. All right, so all of these commands I am executing in the Dapr CLI folder. So this now shows some debug, some info statements from my application that's been starting, and also the Dapr process that's been starting. It will take a couple of seconds before everything is up and running, and that's because this online sandbox environment is quite light, so it's not like super performant. As soon as you see like placement table updated, if you see something like that, where was it? Here, that's the moment it's actually ready. All right. So now our application is up and running. So now the application is up, but the workflow has not been started yet, right? So we first need to, now we are going to call this start HTTP endpoint to start the application. So I'm going to make a curl request, make this a bit bigger, to this localhost endpoint, and start, I'm going to provide 1 as my input argument. So I'm going to do that. Oh, this will be in my curl window. All right, so it went really fast. We got back a tour to accepted, and we got back in the location header. There's an ID, and this is the instance ID of the workflow that's been started. Now we can already see in the Dapr CLI window that workflow completed with status orchestration _ status completed. So we already know that the workflow actually completed. If we scroll up a bit, we also see some application logs that the activities have been called. Okay, so we got this. Scroll a bit further. Now, what we can do is now use this instance ID to actually get back the instance, or to get back the status of this workflow. But I want to actually prevent us from copy pasting this ID out of this header into something else. So what I did is I can actually execute this curl command. And that actually extracts the instance ID from the location header and puts it in an environment variable. So I'm going to run the workflow again. It will create a new ID, and this new ID will be captured in this instance ID environment variable, and we can use the environment variable in subsequent interactions when you want to get the actual state. So I'm running this again in the curl window. All right, so we can already see in the logs it's completed. But if we echo out the instance ID, so we get back like 3231. So that's the start of our instance ID. And now we can use the get command of the workflow management HTTP API to get the status of this workflow. So I'm going to make another curl request now. And this is not going to my workflow application, but I'm targeting this directly to the Dapr process that runs next to my workflow application. So it's still localhost because Dapr always runs next to your application, but it's a different port. So this is the port where Dapr runs. Then it's the version 1 of workflow because workflow is now a stable API. And then it's always workflow/Dapr, and then you provide the instance ID. And in this case, it's an environment variable. So I'm going to run this in my curl window. It's a bit squished here. Let me make this a bit bigger. Oh, it's still squished. So here is the output of this get command. So what you get back is this JSON object, which contains the instance ID. It contains the name of the workflow. You can see when the workflow was created, when the workflow was last updated. You'll see the runtime status, it's completed. And it also contains properties, which usually contains the input 1 and the output 1, 1, 2. I think it's missing the 3, I think. It's been cut off. All right, so it's important to realize that whenever you execute a workflow, you never get back the result because it's asynchronous. You always need to do a get command to get the result. Okay, we can actually stop this. And I'll quickly check again if there are any questions, but first let me finalize this chapter. I want to explain a bit about workflow state and replay. So as soon as you start a workflow, all of the state changes will be persisted to a state store. So I've created this animation to give like an indication of what's going on. So if a client schedules a new workflow instance, there will be a lot of communication between the workflow application, the Dapr Workflow engine, and the state store. So I'm gonna play this. I'm not sure how well this will actually looks in the webinar environment, but you can always play this for yourself in your own environment, of course. So we schedule a new workflow instance. So the workflow is started. Then we start a new activity, and then also the inputs and outputs of the activity are then persisted to the state store. When the activity 1 is done, it won't immediately start activity 2, but it will replay from the top. It will read the information from the state store because activity 1 was already completed. Then it will execute activity 2. And again, it will like persist all of the inputs and outputs to the state store. Once activity 2 is completed, again, it will replay from the top. It will get the information from activity 1 and 2 from the state store, and then it will do activity 3. And once that is done, it will again do a final replay, and then it finds that all of the activities have been executed. It reads everything from the state store, and then your workflow will be finished. And then it will also store the output in the state store. So there's a lot of I/O happening when you actually are running workflows, but that's intentional because we want to do all of these stores to the state because at any moment and the application might fail. So we want to do all of these checkpointing to make sure that we can actually easily get back in a good state. Now we didn't actually see where our state was stored because with Dapr you can configure any Dapr compatible state store that's compatible actually with actors to be the state store for workflows. And that's because Dapr Workflow is built on top of the Dapr Actors system. So Dapr Actors is like a separate API that you can use to write actors. But Dapr is using that internally to store the state of the actors and to store the state of the workflow, but also of the individual activities. So in this case, the state store that I'm using is the default state store. When you install the Dapr CLI locally, you get a Redis container. So I'm using that as the state store. You only need to make sure that whatever state store you use, you need to check if it's compatible as an actor state store. And then you need to set the actor state store field to true. So that's one thing to take into account. And in case we are using Redis now, I can actually look up the keys now in Redis that contain the data for this workflow. So I'm going to do a query in Redis where I want to list the keys that contain this string. So basic, and then double pipe, and then Dapr internal default basic, because that's the name of the workflow, and then dot workflow. So if I run this in the Redis terminal, we get back a lot of information here, because there are actually a lot of keys that match this, and that's because the workflow is replaying a couple of times. So for each instance, so here is instance 323, there are a lot of like history checkpoints going on that contain the execution state for this workflow. Now, now even although you can see where Dapr stores its state and where this is located, you should not actually interact with the state directly. So you should leave it up to Dapr how this state is being managed, and there is a workflow management that you should use if you want to clean this up or if you want to get rid of it. So it's not recommended to interact with this state in any other way than via the Dapr API. All right, let's move on to the next challenge, and I can be very quick about this because this is about the first workflow pattern. So when you are doing workflow as code, there are different patterns that you can write, and the first one is actually very familiar to what we just saw, because it's about task chaining. And you use task chaining when you want to enforce a specific order between all the activities, and that's because there is likely a dependency between the activities. And so maybe you first need to execute activity 1 before you can continue to activity 2, because probably you need the output of activity 1 as an input for activity 2. Or maybe activity 1 does something to an external system, and that needs to be done first before you can do this other activity, which also does something to an external system, which has a dependency, what happened in activity 1. So with task chaining, the order is of importance, and that's why you create this chain of activities. I'll just run quickly through this sample, since it's very similar to the first one. So I'm starting this with just one string input, this, and then I'm calling 3 activities, which just simply append a word to make like a sentence, and the output is this is task chaining. I will just show the program file again. So we are registering our chaining workflow. We are registering our activities. I am calling this start endpoint, and we are scheduling this chaining workflow, and we're giving it an input of this. And I will only show the workflow itself, but not show the activities because they don't contain that much. And so here is the run async method again. And this is the chain of the 3 activities, where the output of the activity is always used as an input for the next one. And the same is true for number 2. And then the third one is actually our workflow result. Okay, let's run this. Let's first move to the right folder, task chaining folder. Let's build the solution, but it should be quicker now because we've downloaded the dependencies on this environment. And once this is done, yeah, it's done. Then we're going to run the application again. All right, and if I now immediately start the workflow, so to call this endpoint and capture the instance ID in a variable. So let's run this in the curl window. So when I'm very quick, you'll see this error: processing operation, Dapr built-in actor not found, retries. So you can actually ignore that because we are actually sort of too soon. Dapr has not fully initialized yet because it's just a very slow environment. But Dapr is actually like using its own retry policies to actually get to a healthy state. And then finally, you can see that our workflow is executing. We can see the application logs from all of the activities. And we can also see that the status is completed here in the logs. And again, you can also use the other get API to actually call the sidecar to get the same information that the workflow is completed. Okay, so this is the first workflow pattern, task chaining, most basic one, probably the one that you will also most often use. All right, we go to the next pattern, and that's fan out, fan in. So the fan out, fan in pattern is really useful when there is no dependency between the activities you want to call. So in this overview, we will start a workflow, but then we will immediately call 3 activities and we'll try to execute them like independently, so as close to each other as possible. So you could say it's sort of parallel. It's not guaranteed to be parallel, but it will be as much in parallel as possible. The nice thing about the fan out, fan in pattern is first the fan out happens. So you all of these activities are called, and I'm showing 3 here, but these can also be 1,000 activities, right? But then you can instruct the workflow to wait until all of these activities have been completed, or until the first activity has been completed. And so you can do like a when all or when any in the workflow, and that is the fan in part again. So then you can actually use some aggregation over the output of all of these activities. So that's quite powerful. So the sample I'm going to run in this track is this. I'm going to start a workflow, which is an array of words, and I want to find which word is the shortest one in this array. It's a bit of a silly, small example, but it does prove the mechanism behind it. So what I'm going to do is for each of these words in the array, I'm going to call the same activity. And with fan in, fan out, you don't necessarily always need to call the same activity. Those can also be like different activities. But in this case, for every word, I'm going to run the same activity, which in this case simply returns the length of the word. And so the output here, so the aggregation at the end, when they have all been executed, is, okay, give me the word that's the smallest, and that should be is. So quite a basic example, but I think it's a good example to see how this pattern works. So let's have a look at the workflow. That's this one here. So this is the header run async method that needs to be overridden. We first do like a short like input check if there's actually any valid input. And what happens then is we create first a new task, a list of tasks of word length. And this is the output type of the activity that of the activities that will be called. So once we have this new list, we will do a for each loop over all of the individual strings in the input array. And here we are using the context to call the activity get word length. And that will give us back a word length object. And this is the input that we're providing. But notice that we are not using await here. So we're actually not awaiting this call. We are just merely adding this task to call this activity to this list of tasks. And this is the place where the magic happens. So here we do await and do a task when all, and this is then the list of tasks. So this is the moment where the workflow application signals to the Dapr Workflow, okay, now go and schedule all of these individual tasks. And then the workflow application will actually run all these individual tasks. And at a certain moment, all of these tasks are ready, all these activities, and then the control comes back to the workflow application, and we can actually continue with the next line. And that's actually checking the results and then ordering them by length, and then choosing the first one, which gives us the shortest word. Okay, so let's run this. I'm skipping over the program.cs file because there's nothing really new in here. So I first need to run the application. Here we go. So let's move to the right folder. I am building the fan out, fan in solution. Okay, it's built. Running the solution. There we go. And now I can actually start it. So again, so here you can see that I'm starting it with a payload of an array of strings here. And again, we're capturing the instance ID, so we can actually use the get request to get back the status. So let me run this. Again, we were a bit too fast here. So yeah, now it's actually running, and we can see here in the application logs that the get worth length activity is called with each of the individual inputs. We can also see that the workflow is actually completed. So let's see if the result is actually the word is by running again this get command and specifying the instance ID. And so the input is which word is the shortest, and the Dapr Workflow output is actually is. Okay, so this was a quick example of how to use the fan out fan in pattern. All right, so the next pattern is the workflow monitor pattern. And that's a very useful pattern if you want to execute like a recurring task. So maybe you will have a daily or a nightly job running that cleans up some cloud resources, for instance. So what you do there in a schematic way is you first run an activity to do a cleanup job, or maybe you're checking a status of something, and then you want to wait for a certain moment of time. So you instruct the workflow to create a timer, and when that timer expires, you actually instruct the workflow to continue as a new instance. Now, this is something different than the replay behavior of a workflow. So the replay behavior happens when something is actually continuously running and executing. But continue as new means you start this instance of a workflow as a new fresh instance, and you can forget about all of the historical executions. So it's basically like sort of a do loop is actually what's happening here. Okay, so in the sample application that I'm going to run, we have this situation. So we start with a numerical input. We start with 0. Then we have a check status activity, which simulates getting a status from some kind of an online resource. Then we have an if statement to check, okay, is this status, is it ready or not? If it is ready, we just immediately complete. So we stop the workflow. And it then gives back an output and then checks, okay, how many times did you actually do this cycle to actually come to this status. If it's not ready, then we are creating a timer. We wait for 1 second in this case, not to wait too long. We actually increment this status counter, and we continue as a new instance, and we provide this counter as the input for the new instance, because we're also starting with a numerical input here, so we can actually update that input and provide that when we continue as a new instance. All right, let's have a look at the workflow now. So this is the monitor one. So here we have a run async method again, and we have the integer as our input. And so the first thing is, business as usual. We just call an activity, and it's called check status. We provide the counter as our input, and we get back a status. So if the status is not ready, then we are using the context to create a timer. And so this is a method on the workflow context, and we provide a time span. In this case, just 1 second. We then also increment the counter, and then we use the continuous new method to on the context and providing that updated counter. If the status is ready, we just skip this part and just return the workflow. Now, if you look at the activity here, there's not a lot happening here, but we do a console write line, and that also then includes the input. So we can just keep track of how many times this has been executed, and we then use like a bit of randomization to sort of randomly determines if this state is ready or not, just to make it a bit more interesting to run this demo. All right, so this is our application startup. So we have a post endpoint that we're going to call. This is start/counter, and we're going to start with 0, and this is going to start our monitor workflow. All right, let's run the application. Let's build the application. All right, and let's run it. using multi-app run again. Okay, so our application is starting up and Dapr is starting up. So now let's call this workflow. So we're calling start/0. So we're starting at 0. Call it in a curl window. Again, it complains that actors is not ready yet, but it will be soon. And once it starts, we actually will see some console logs. Yeah, it's now ready. Yeah, and here we see that the workflow is like restarting, right? So it's already, and it's in this case it restarted like until we have received input 4. Okay, and now we actually see we see the status orchestration status completed. So if we do a get now to check the status, we execute this curl command, and we see that the output is now status healthy after checking 4 times. All right, this is like a very basic example of using the monitor pattern, but yeah, it's a very powerful thing to keep doing things on a recurring thing, especially if you include like some business logic there. Okay, I can stop this and we can move on to the next one. Yeah, so this is also a very nice one. So the next pattern is the external system interaction pattern. So this pattern is very useful if you want to pause your workflow, if you want to introduce a waiting step in your workflow, and you want to have another event controlling the next flow. And so in this case, it can be very useful for like an approval workflow. So maybe you want to order like an expensive laptop and you need like manager approval for this. So initially the steps like before this wait can be like, okay, process the order and determine what the total price is. And if the price is above a certain threshold, then notify a manager. And then the manager will review this order and it will use their application to send back an event to this workflow instance. And we can then inspect this event, the payload of the event, and then we can continue with the workflow, but we can actually make a decision based on the payload of the event. So something can be approved or not approved, or whatever your business logic is. So we can actually determine what kind of branch in the workflow we'll be following based on the event that's coming into your workflow. So in this case, I do have like an example of like an order approval workflow. So I'm actually having an input of like an order with rubber duckies, ordering 100 of them, and the total price is like 500. So my first if statement in my code is the price over 250? In case yes, then I'm waiting for an external event because I have, in this case, I'm assuming that my manager is already notified and that an approval event is coming in. Once the approval event comes in, then I'm checking the payload of the event. Is it approved? Yes, I can process the order, and then I will send a notification, and then I'm stopping. In case the order is not approved, I'm not doing anything with the processing the order. I'm just sending a notification that it's not approved. And in case the price is not over 250, then I'm like automatically processing it and sending a notification. So let's have a look at the code here. So this is our external events workflow. Give it a bit more space. All right. So again, I have my run async method. So now I'm using like a POCO, like an actual .NET object as my input, which is like a serializable object. I already have like a default approval status that I'll be using later. So my default is actually says I'm already approving it. So that's my default. I'm first checking if my order has a total price of over 250, right? So this is my first if statement. And then I have like a try catch block. And in the try, I am waiting for an external event. And you always need to specify the type of the event, which is in this case approval status. And you always need to specify an event name. In this case, I'm expecting an event with the name of approval event. Now, the second argument is a timeout argument. That is optional, but I am definitely suggesting you should always use this, because if you don't specify a timeout event and you're just your workflow is just waiting for the event, but what if that event never comes in, right? So you always need like a sort of a fallback solution in case the event does not arrive. So I think business-wise, it's always good to have like a backup solution to always specify a timeout event. What if it never arrives? Well, in that case, you need to do something else. So in this case, if an event does not arrive and a timeout event is triggered, we actually receive a task cancelled exception from the Dapr workflow. So in this case, the timeout is triggered. I prepare a message and I'm just calling the send notification activity with this message. But of course, it depends on your business logic what you want to do here, right? But in this case, I'm just simply calling an activity and just sending a notification. So if the catch is not triggered, that means that we have received an approval status event. So I'm checking the payload if it is approved. If it is approved, I'm calling my next activity and it's processing the order. And then finally, I am creating the final message that's based on the is approved. So it's either order is approved or order is rejected. And I'm sending a notification with this notification message. So again, it's a bit of a simplified solution, but you can already see that we're already introducing more and more business logic with if statements and try catch blocks. And that's very typical for workflow as code systems. Let's see. So we're calling this a start endpoint. We are getting an order. We get the Dapr workflow client injected again. So I'm calling this external event workflow. We are now specifying the instance ID of the workflow. So this is something new. So this is like an optional argument. If you don't specify an instance ID, Dapr will generate one for you. But in this case, we already have an ID, and that's the order ID, and I'd like to use that as my instance ID. So I'm specifying that, and I'm specifying the order, and that's it. Okay, so let's run this. Let's move into the right folder. Let's build the solution. Make this a bit bigger again. Okay, and now let's run the solution. Okay, so now I need to do like two things. So the first thing is I actually will start the workflow, and as you can see by this payload here, so here's the data. So this is an order. So this is the order ID. There's a description. There's a quantity, and there's a total price. As you can see that the total price is 500. So I'll be triggering that if statement that I actually need like an. So I'm actually will be waiting for an external event. So. And there was a timeout of, let me check, I think it was 120 seconds. Let me move up here. Yes, so we're waiting for this event, and we have a timeout for 2 minutes. So what I'm going to do is I'm going to start this workflow, and then within the 2 minutes, I will actually raise an event to this workflow, which in this case is an approved event. So let me first start this. Okay, so I'm going to run this, and I don't need to capture the instance ID now because I'm actually providing the instance ID because that's the ID of my order ID. So that's why I'm not capturing anything in here. Okay, so now the workflow is here, but now it's actually waiting. So now I will send like an external event, and in this case I am sending the external event directly to the Dapr sidecar. And so this is not what you would do in production. In production, you would actually wrap this call or use the Dapr SDK in another endpoint. But in this case, I'm calling the Dapr sidecar. So I'm to this endpoint. So this is my Dapr sidecar address, the version 1 of the workflows, Dapr, and then this is the order ID, which is also now our instance ID. And then it's /raise event, and then this is the name of the event. And then I'm also specifying a JSON payload as well. So this is the data that I'm sending to the event is approved true. Let's see if I'm still within the 2 minutes. I'm too late. So we get back an error code. failed to raise event on workflow, failed to raise event on workflow, workflow not registered. So I think this actually means that I was like too slow, and this already completed because I was just talking too much. So let's actually run this again, and then I'll be a bit quicker. So we're going to start the workflow. All right. Oh no, I think something else is happening now. Something's failing. Okay, in this case, something else might be failing. Let me restart my application. Okay, maybe the environment had a glitch or something. So I'm restarting my application now. I am going to make the call to the workflow again. All right, so that's all good. And then I am raising that event. Okay, I'm raising the event. Yeah, I think it's worked because now we get back orchestration status completed. So let's actually do the get request to make sure what the thing is. So, oh, it still says too late, timed out. Okay, well, I'll just continue for time's sake, but I think you get the picture on how to work with this external events flow. Let's move on. So another pattern that you can do is called child workflow. So what you actually can do, you can have like a parent workflow, and the parent workflow you can actually call child workflows. So you can actually nest your workflows. Now, why would you do this? Well, maybe you have like a piece of reusable code, some activity steps that you always run in a specific order, and maybe you want to reuse that across many different workflows. And so it's like you do some composition of your workflow. So maybe you do this also for like to be able to test it more easily. So instead of like having one gigantic workflow of 100 steps, maybe you can have like 10 smaller workflows of each 10 steps. In this case, I am calling a workflow that receives, or that I start with an array of 2 items. And then for each item in the array, I'm calling the same workflow. So in this case, I'm just executing 2 child workflows of the same type, and then aggregating the result and then ending it. So let me quickly show it because we're already a bit short on time, I see. So this is my parent workflow. And I receive a string array as an input. I create the list of tasks of the output that I have, and then I'm iterating over the inputs. And I'm now use the context to use this method called child workflow async. So instead of call activity async, I'm now calling child workflow async. So this list of tasks now has all of these tasks which define to call child workflows. And then I'm using the same fan out, fan in pattern to actually do await task when all, and then providing all of the tasks of the child workflow. Due to the time, I am not running this because I still have some other challenges I want to go through. All right. So this is an important one because this is about resiliency in workflows and compensation actions. So one of the additional things you can do with Dapr Workflow, which is already very resilient by default, because if the whole process collapses, you can actually restart the process and Dapr will sort of self-heal and will continue the workflow. But for instance, what you can do when you call an activity, you can provide some resiliency policy that will retry the activity in case it fails. So that looks like this. Here we go. This one. So this workflow here I'm specifying a default activity retry options. So that is of the type is workflow task options, and in those options is a retry policy property, and that is a new workflow retry policy, and that has like several configurable options. In this case, it's like a constant retry of 3 times, and the first item that I want to retry this is after 2 seconds. But you can also configure like exponential retries as well. And so this is now a new default activity retry options, and I can provide this as my final argument when I'm calling activities. So I'm first specifying the activity name, the activity input, and then I specify the retry options. So another thing that is happening in this workflow is, in this case, I have this try catch block, and I am calling an activity called division. Now, what if this workflow will fail? Well, then first the retry options will be executed. So this will be executed for maximum 3 retries. If it then still fails, then there will be an exception, and that exception will be wrapped in a workflow task field exception. So I'm catching this workflow task field exception. I can then inspect the failure details, as you can determine in detail what the actual underlying exception is. And in this case, I'm forcing it to actually be like a division by 0, which actually in .NET results in an overflow exception. And if that's the case, I am running a different activity. So this is called a compensation action. So I can actually provide like an undo action, which is just a new activity that I'm writing myself to undo one of the earlier steps. So my first step that I'm doing here is actually doing a -1. So I'm doing some kind of calculation here. I'm subtracting 1. And my compensation action here is actually do a +1 here. So again, this is a very overly simplified solution, but I think you understand how to actually apply this to your own business logic. Another thing that we haven't seen yet, there's a method called set custom status. So that is a method that you can run on the workflow context. So you can always provide a bit of extra custom status to your workflow instance. So you can also, if you want to keep track or add some more debugging logic or something, you can actually provide this with not just a string, but with any object that you want to provide a bit of additional status. Okay, I think there are like 2 more to go. So this is a more realistic challenge. I'm not going to run them because I think this is nice if you just explore this on your own. This is a more realistic example that actually interacts with like a state store. It also interacts with another application, a shipping application. And so it uses the fan out, fan in pattern. It then has some business logic to process a payment. So this is, of course, still simulated. Again, it interacts with a state store using the Dapr API. It then uses Dapr PubSub to communicate with the application. So this interaction was with service certification, but now it's using PubSub. And this shipping application is then also using PubSub to actually communicate back to the workflow application, and then raises an event because the workflow will be waiting until it gets back a confirmation about this registration. And then we determine if it was successful. If not, we apply a compensation action to actually reimburse the customer because it's paid for it here. So we reimburse it. And if it is successful, then we immediately end. So this is definitely like a more complete example for like interactions with multiple applications. So yeah, definitely have a look at it on your own. Okay, so this part is definitely important because Dapr Workflow is, of course, about authoring workflows as code, but you also need to manage these workflows. So the Dapr has a workflow management API, and you can not just start the workflows and get some information, get a status about them, but you can also suspend a workflow. And it means like I'm pausing a workflow. You can also then resume a paused workflow. You can also terminate a workflow. So maybe you have like a workflow which is completely out of control, or maybe it is stuck or doing some weird things. Then you can terminate it so it stops executing. And you can also purge a workflow instance. So purging means we are removing the state from the underlying state store. And this is very important because Dapr Workflow does not do automatic cleanup of your workflow state. So as soon as you start using workflows, you'll just adding state continuously to your state store. And yeah, you are responsible yourself to deal with the state management. So you can do that via this purge endpoint. What you should know is that all these interactions are based on a workflow instance. So you can suspend or resume, terminate or purge just one workflow instance. So at the moment, there is no way to do like a batch terminate or to a batch purge. That's something that is definitely needed in the future to quickly purge like historical data, for instance. So at the moment, it's very important when you run Dapr Workflow production to always make sure to store your workflow instances somewhere else to make sure you can access them and then purge them efficiently later. This also comes with like a demo application which actually runs like an indefinite workflow, but given the time, I am not running that now. The final part, that's about some challenges that there are with workflows. So the first challenge that you have is your workflow code need to be deterministic. And what does it mean? Well, your workflow code will be run many times due to the replay nature, right? So it won't be just run once, but it will be running multiple times. And all of the code that's in here should be deterministic, meaning for all of the same inputs, it should always result in the same outputs. Now, some examples of non-deterministic code is, for instance, directly using GUID, new GUID in your workflow, because for every replay, you'll get a new order ID in this case. And if you're using this order ID as an input argument for calling this activity, all of the input arguments are persisted to the state store, and all of the output arguments are stored as well. And they're also looked up in this way. So you can easily get a mismatch between state from the state store and state at the runtime. The same is true for datetime U2C now. So timestamps should not use timestamps in your workflow. So luckily, most of the Dapr SDKs has some helper methods for this. So for instance, there is a context new GUID for the .NET one. That's not yet on the Python SDK, I think. There's also a current U2C datetime property on the context, and that is available in the Python one. So you can use that instead of like using the datetime stamps. For anything else that's non-deterministic, put that in an activity, because activity code can contain anything, and that's because the inputs and outputs of these activities are stored. Another important thing is that activities should be idempotent, meaning that whenever you execute an activity, if you execute it multiple times, it should not have any like unwanted side effects. And that's because Dapr guarantees at least once execution in case an activity fails. So an activity could be run twice, but yeah, it means that in case an activity fails, then maybe some code is already executed correctly in your activity. So you really need to think about all of the APIs that you use in an activity. Are those APIs idempotent, right? So for instance, if you insert a record in a SQL store in a Postgres database, can you run that insert twice, or will you get issues? So maybe it's safer to first do a read and then do a write, or do an upsert instead of an insert, those kind of things. Another thing to think about is check the payload size of your workflows and activities. So as you saw in the video, and I've also mentioned it, there's a lot of I/O happening between your workflow application, between the sidecar and the state store. So it's important to make your payloads as small as possible so that the serialization deserialization is like optimal. So this is like an example how not to do it. So for instance, if you are calling an activity to retrieve a very large JSON document, and you are then passing that large JSON document from one activity to the other one, and that means that first this document is stored, saved in the state store as an output argument, but also as an input argument for the next one. And so this document is stored twice. So in this case, it's better to just combine those two activities into one activity, and you retrieve the large payload, you update it, and you save it all in the same activity before continuing. The final tip that I have is related to versioning. So versioning workflows and versioning workflow as code in specific is a tricky thing. I always recommend to use like update a version number as the name of the workflow. As you see here now, I have versioning workflow 1, and here I have like versioning workflow 2. So this is a safe way of doing this. And then why is that? Well, let's say you have a workflow, your first iteration is running, you have maybe there are like long running workflows. So maybe the execution takes a couple of days before they complete. You have like updated the workflow, and maybe there is like a breaking change, which is likely. So you deploy that new version, but there are still workflows in flight, meaning they have not been completed yet because they're like halfway through the execution. Now you have a new workflow definition, a new model that's running, but you still have the old state in the state store, and this state is not compatible with the new version anymore. And so you'll run into issues when you run this updated version. So since everything is always persisted with this key that includes the workflow name, it's always recommended that you then just include a version number in this workflow name. So you never have like issues with multiple workflows, because if you deploy this new version, you still have the old version in there as well. So you definitely use a version number, but you also keep the old version in your solution. So existing workflows can still execute this one, and new workflows can start using this new one. This does mean that your client, which is responsible for starting this new workflow, your program CS file is of course updated to use this new version.